morning, everyone. I am Don Paulo Arnado, and together we are the Group 3 reporters of this class. Hope you have a good day today as we would like to present our topic for today's meeting, the leveling, its theory and methods. But first, we will know the flow or the order of our topic session. First, the theory of leveling, which will be presented by yours truly, Earth's curvature and refraction, Kenneth Bryant Cartolina. Methods of determining leveling, Charwell John Gonzalez. Difference and elevation instrument for direct leveling, Mayora Althea Amor Penuela. Differential leveling, Charles Joshua Tambagal. Profile leveling, Joarto Tamuntok. And sources of errors, which will be presented lastly by Krisa Joy Olive Balatia. First, we will learn what is leveling. Leveling is a process of determining the height of one point relative to another. It is used in surveying to establish the elevation of a point relative to a datum, or to establish a point at a given elevation relative to a datum. Effective land leveling reduces the work in crop establishment and crop management and increases the yield and quality. The leveling theory. It is to determine the topography of sites for design projects, set grades and elevations for construction projects, compute volumes of earthwork, provides a horizontal line of sight, a line tangential to a level surface at the point where the instrument stands. And in agriculture, leveling is the process of pressing the pieces and cramps of plowed soil into the ground to create a level surface. The leveling of plowed soil is beneficial because the leveling of plowed fields prevents the top fertile soil from being carried away by strong winds or washed away by rain water. The leveling of plowed fields helps in the uniform distribution of water in the fields during irrigation. The leveling areas of application includes layout construction projects according to specific design, calculate earthwork volumes, investigate drainage characteristics, develop maps showing general ground configurations, and monitor earth subsidence.
Good day everyone, I'm Kenneth Brian Cartolina and today I'll be going to discuss to you the Earth's curvature and refraction. So ano po ba yung tinatawag nating curvature and refraction? Ang curvature would be mean Earth's level surface is lower than horizontal. Ibig sabihin na ang anyong lupa natin ay mas mababa kaysa sa horizontal. At ang refraction naman means your line of sight will be lower than horizontal but not by as much as the curvature so it doesn't fully cancel out. Ibig sabihin, ito yung mga nakikita mo na mas mababa sa horizontal ngunit di bababa sa curvature. So para mas maunawaan ninyo, I will show to you some figures na makakatulong sa pag-intindi ninyo sa topic na ito. Curvature correction. It is the effect of the Earth's curvature is the amount by which the horizontal line departs from the Earth's surface, which is the level surface. Kung nakikita nyo dito sa figure, ito po yung tinatawag nating horizontal line which is approximately equal to K at yung K po natin is the horizontal distance of level surface distance in kilometer. At ito po yung tinatawag nating R Earth or the mean radius of the Earth at yung radius po ng Earth natin is approximately 6,371 kilometer. But the true value of it or the true value of the radius is 6,371.1 kilometer. Ni-round off lang po natin. So, ito po yung tinatawag nating Earth surface or the level surface. Yung HC naman po, ito yung curvature correction natin and has a value of 0.0785 K squared. So, ang tanong po kung saan po ito nakuha o saan po ito nanggaling. Dito po, where HC is the correction due to curvature and K is the horizontal distance of the level surface distance in kilometer. Derive formula using the Pythagorean theorem. Kung naalala po ninyo, yung Pythagorean theorem natin is a squared plus b squared equals to c squared. Opo, magkalintulad lang po sila sa nakikita ninyo. We have the r earth squared plus k squared equals to r earth plus hc squared. So, we have r earth squared plus k squared equals to r earth squared plus 2 times r earth times hc squared plus hc squared. Kung nagtatanong po kayo kung saan po ito nanggaling, dito po. We simply use the FOIL method which is commonly na ginagamit natin in solving quadratic equation. So, kung napapansin nyo, we have a negligible value. Bakit po naging ganito? It is because napakababa po ng value niya para isali pa natin in finding or solving the correct or the curvature correction. So, we simply cancel out the like terms. So, ito na lang po yung natira. K squared equals to 2 times R earth times HC. So, we have the HC equals to 1 over 2 times 6,371 K squared. So, kung nagtatanong kayo kung saan po yung nagaling yung 1, it is because nag-transpose po tayo ng HC sa kabilang side at K squared sa kabilang side para di po mag-negative yung value natin. Naglagay po tayo ng 1 sa numerator. So, ganyan po yung nangyari. So, we have the HC value which is the 0.000785 K squared in kilometer. And in meter naman, we have 0.0785. So, ito po yung commonly na ginagamit natin in solving po. So, next, refraction correction. It is the rays of light passing through the Earth's atmosphere in any direction other than vertical are refracted or bent from a straight path. This bending usually takes place in a direction towards the Earth's surface under normal condition of temperature and pressure gradients. Such bends rays of light tend to diminish the effect of curvature for slight amount, normally about 14% or 1/7 of the curvature effect. Ibig sabihin po, yung refraction correction natin has a value of 1/7 of the curvature or the curvature correction. It is due to the curvature effect. So this is the figure. So yung HCR po natin has a value of 0.0675 K squared. Ito po yon. Then, yung K natin, as usual, is the horizontal distance of level surface distance in kilometers. So, kung naalala nyo yung sinabi ko, yung refraction correction natin is has a value of 1 over 1/7 HC or correction or curvature correction. It is due to the curvature effect. So we have here the HCR equals to HC minus HR. HCR equals to HC minus 1/7 HC. Ito po, we simply substitute the value of HR. So HCR equals to 6 over 7 times 0.0785 K squared. So kung nagtatanong kayo kung saan po nanggaling yung 6 over 7, ito po yung katulad sa algebra po natin. So, ito po yon. Yung HC po dito, meron po talaga yung 1 na value. Kasi pag wala po yung 1, magiging 0 po yan. So, we have the 1HC minus 17HC. So, dito, kung nakikita nyo, naging 7/7 siya. Kasi po, nag-factor out po tayo. Dahil yung 7 divided by 7 is equals to 1 po. Mas madali po siyang isubtract sa 1/7 pag ganito po yung ang given. So, we have the 6/7 HC. At yung value po ng HC natin, kung naalala ninyo, is 0.0785 K squared. So, ganyan po. So, we have HCR is equals to 0.06729 K squared. So, I have here a sample problem. A man standing on the ground can see just the tip of the tower 25 kilometers away. If the eye of the man is 1.8 meter above mean sea level, determine the height of the tower above sea level considering the curvature and refraction correction. So this is the figure. For our solution, we have this figure. Kung nakikita po ninyo, this is the man at yung ang eye po daw ng man ito is has a distance of 1.8 meter above sea level. At ito po yung tinatawag nating point of tangency. Ibig sabihin, hanggang dito lang po yung nakikita ng taong ito. So, in finding the height of the tower above sea level, first, kukunin muna natin yung value ng x. Value ng x. So, please take note of this, that the value of our HCR is equals to 0.0675 K squared. So, we have here 1.8 meter equals to 0.0675 K squared. We simply substitute the value or the height of the man. So, we have K squared equals to 26.667 meter. So, paano po ito nangyari? We simply divide both sides by 0.0675 para po ma-cancel out natin ito at maging K squared na lang po yung natira. Then, 1.8 meter divided by 0.0675 at naging ganito na po yung kinalabasan. So, square root of K squared equals to square root of 26.667 meter. So, in-square root po natin ito para po ma-cancel out natin yung squared dito. And square root po dito. Pa rin kasi we need to square root both sides. So, ganito po. After which, the value of our x is equals to k. And the k is equals to 5.164 meter. So, nakuha na po natin yung value ng k. Ang next po natin gagawin is kukunin na po natin yung tinatanong sa problem, which is the height of the tower above sea level. So, we have here HCR equals to 0.0675 K squared. At itong H na ito, ibig sabihin, height po ito ng tower. Hanapin po natin, di ba? So, we have the H equals to 0.0675 times 25 minus 5.164 meters squared. Ang tanong po, saan po ito nanggaling? Yung K po natin is dito. Ito po yung K natin. At we simply substitute the value of X na 5.164 meters. So, naging ganito po yung kinalabasan. So, we have H is equal to 26.56 meter. At Ganito na po yung sagot niya. At that is the final answer.
At kung gusto niyo po ng another example sa topic na ito, you can search on YouTube. And let's proceed to the next reporter. Thank you.
Hi everyone, my name is Jan Oliveros Gonzalez from Group 3, and I will discuss about a topic in leveling, which is methods of determining difference in elevation. Differential leveling is the process of determining the difference in elevation between two or more points some distance apart. So, in differential leveling, we also uses our knowledge in calculus in which talks about geometry and trigonometry. This type of math helps us to measure angles and distance on the ground. They then interpret the data accurately, plotting such information, boundaries, and locations of structure on a map. Definition of terms. The different terms commonly used in differential leveling work are graphically illustrated from the previous slide. A cursory look at the figure may imply that the points along the leveling route all lie in a straight line. It is important to understand that it is not always the case in actual leveling work. The points in the instrument stations may in fact be positioned in plan along a zigzagging pattern. There are some consideration in differential leveling, and such as benchmark or BM. So benchmark is a fixed point of reference whose elevation is either known or assumed. Bauxite or BS. A bauxite is a reading taken on a rod held on a point of known or assumed elevation. Next, foresight or FS. Foresight is a reading taken on a rod held on a point whose elevation is to be determined. Next, bauxite distance or BSD. Bauxite distance is measured from the center of the instrument to the rod on which a bauxite is taken. Next, a foresight distance or FSD. It is the horizontal distance from the center of the instrument to the rod on which a foresight is taken and referred to as the foresight distance. And next, turning point or TP. Turning point is an intervening point between two benchmarks upon which point foresight and bauxite rod readings are taken to enable a leveling operation to continue from a new instrument positioning. And lastly, height of instrument. Height of instrument or height of collimation is the elevation of the line of sight of an instrument above or below a selected reference datum. Um, Methods of determining difference in elevation in its cases. So in case 1, when the base of the object is accessible. And case 2, when the base of the object is not accessible. And it is consist of A, when the instrument is shifted to the nearby the place and the observation are taken from the same level of line. B, when the line of a sight of two instrument is sitting is different. And another case 1, when the difference is smaller than staff height. Case 2, when the difference is larger than staff height. And C, when instrument station and top of the object are not in the same vertical plane, the cases is is when the base of object is accessible. So we can see the picture that shown from the screen. It is the another example of differential leveling as what. And when the 2 points are at a known horizontal distance, then we can find out the distance between them by taking the vertical angle. The observation of it is if the vertical elevation from the point to be observed to the instrument axis is known, and we can calculate the vertical distance using the trigonometry. So these are some examples of illustrative problems. So first is level notes from this is level notes from benchmark 1 to benchmark 4. Next, level road from benchmark 1 to turning point 2. Next, level road from turning point 2 to benchmark 3. Next, level road from benchmark 3 to benchmark 4. Solution. Computation of height of instrument and elevation of stations. B. Determining backside and foresight sums. C. Tabulated solution. And D. Arithmetic check. So, for more knowledge, there is an example video to understand this topic well. I have some example here po. Display.
Okay, so good morning class. For today, let's have the sample problem for differential leveling. So, you know already what is a differential leveling. Please read or understand the notes I already gave you. Solve here the sample problem for differential leveling. So from the given differential leveling notes, compute the elevation at each points. So you have the turning points TP1, TP2 up to TP7. And then compute for the elevation of benchmark 2. Okay, this one. And then the difference in elevation between the benchmark 1 and benchmark 2. And then the difference in elevation between the turning point 3 and the turning point 6. So to compute that, you have the backside for the benchmark 1 and then the turning point 1 to turning point 7. So backside meaning that is the plus side, and the foresight that is the backside is the minus side. Backside, yes, is the plus side. Foresight is the minus side. Okay, so to compute for the height of the instrument for the benchmark 1, that is, so the height of instrument, okay, height of instrument is equal to
So, yan lang muna kasi mahaba yung video. And I prepared a link for this topic para maintindihan nyo po ng maigi. And that's all for today. Thanks for listening, guys. Thank you.
Hello everyone, I am Althea Amor Claude Benuela, and today I will discuss about the instruments of direct leveling. But before we dig deeper to the topic, please allow me to give you a brief information about direct leveling. So based on my research, direct leveling is one of the leveling method used in surveying, including the trigonometric leveling, the barometric leveling, and the stadia leveling. But let's just focus about the direct leveling. So, what is the direct leveling? Direct leveling is the most commonly used method of leveling. In this method, measurements are observed directly from leveling instrument. Based on the observation points and instrument positions, direct leveling is divided into different types. So what are those different types? Those types are simple leveling, differential leveling, fly leveling, profile leveling, precise leveling, and reciprocal leveling. So since we have already reviewed the brief information about direct leveling, we can now proceed to the main topic of my report, which is the instrument for direct leveling. Okay, so auto level, digital level, tilting level, level rods, level vials, telescopes, hand level are the instruments used in leveling. So let's tackle first what is the auto level. The auto level is a naturally leveling elite optical instrument followable amid site overviews and building development to assemble, exchange, or set horizontal levels and grade applications. I have also provided the auto level label diagram below. Next, digital automatic levels are precise instruments used for precise leveling. Operation of digital levels is based on the digital processing of video indications of a coded stuff. At the beginning of measurement, a visual pointing of the instrument into the surface of leveling meters is performed. So this is the components of digital level surveying. Next, tilting level. It consists of a telescope attached with a level tube which can be tilted within a few degrees in vertical plane by a tilting screw. The main peculiarity of this level is the vertical axis need not to be truly vertical, since the line of collimation is not perpendicular to it. The line of collimation is, however, made horizontal for each pointing of telescope by means of tilting screw. This is mainly designed for precise leveling work. So I have provided a tilted level label diagram and the actual photo of the tilted level. Next, level rods. A level staff, also called leveling rod, is a graduated wooden or aluminum rod used with a leveling instrument to determine the difference in height between points or heights of points above a vertical datum. It cannot be used without a leveling instrument. So this is what leveling rod looks like. Next. So next we have level vials. Level vials, also known as spirit level, is the heart of any level. It is also known as bubble level. The name spirit level comes from the liquid inside the level vial. This liquid is a mineral spirit solution with additives which gives the vial its color protection from ultraviolet, fading in sunlight and freezing in the cold. These additives are carefully researched to mix together and never settled out. Level manufacturers also want to make sure that their vials maintain their color and other features for a long time. So this is level vials looks like. So next, telescopes. The telescopes of leveling instrument define the line of sight and magnify the view of a graduated rod. The components of the telescope are mounted into cylindrical tube. These four main components are objective lens, negative lens, reticle, and eyepiece. Two of these parts, the objective lens and eyepiece, are external to the instrument and are shown in the auto level. So this is the telescope. Next. Hand level. The hand level is a handheld instrument used on low precision work or to obtain quick check on more precise work. It consists of a brass tube approximately 6 inches long, having a plain glass objective and pip-side eyepiece. The instrument is held in one hand and leveled by raising the lowering the objective end until the cross line bisects the bubble. Resting the level against a rod or staff provides stability and increases accuracy. This instrument is especially valuable in quick checking proposed location for instrument setups in differential leveling. So this is what hand level looks like. For the references of my report, you can visit these two sites. So that ends my report. Thank you and God bless.
I am Charles Joshua C. Tambagan. Today I will be discussing the differential leveling. Differential leveling is the process of determining the difference in elevation between two or more points, some distance apart. It requires a series of setups of the instrument along general route, and for each setup, a rod reading back to the point of known elevation and forward to a point of unknown elevation are taken. So in short, leveling is conducted to determine the elevation of points on the ground, or if you want to determine the difference in elevation between two or more points. Leveling is used by our surveyor in designing highways or drainage systems so that we will be able to know the amount of excavation, the amount of embankments. Also, we will able to know where is the highest point and the lowest point on the ground. As a whole, levelings used to determine the physical characteristic of a ground. One of the instrument needed is the auto leveling. It will be used to foresight the stage rod. The first picture is the rod or leveling rod. This is a huge ruler which is held or positioned vertically. This is being sighted by the surveyor to determine the height from the ground. The second picture is a tape measure if you want to know the horizontal distance between the 2 points. The third picture is tripod, which where we place our instrument. Fourth picture is plumb bob. This is of course to ensure that our equipment is vertically aligned with the stake. First picture is a marker to know where is the location of our station. This is a stake. The second picture is a compass to know the bearings of the angle. Definition of terms. Elevation. For a particular point, its elevation is the vertical distance above or below mean sea level or any other selected datum. Benchmark. A benchmark is a fixed point of a reference whose elevation is either known or assumed by they may be permanent or temporary. Backsight. A backsight is a reading taken on a rod held on a point of unknown or assumed elevation. It is a measure of the vertical distance from the established foresight. A reading taken on a rod held on a point whose elevation is to be determined is called a foresight. It is represented as a vertical distance from the line of sight of the instrument to the point observed. Height of instrument. The height of instrument or height of collimation is the elevation of the line of sight of an instrument above or below a selected reference datum. Turning point. Turning point is an intervening point between two benchmarks upon which point foresight and backsight rod readings are taken to enable a leveling operation to continue from a new instrument position. We have here the sample problem. Determine the difference in elevation between point A and point B. We have here a point A and point B. In this case, we put the benchmark 1 at the point A and also the stage rod. So in this case, we don't know the exact elevation of point A above the mean sea level. So we assume that the elevation is 20 meters. We assume that the elevation of point A is 20 meters. And take backside reading of 3.851. So upon getting the height of the instrument, we must sum up the elevation and the backside reading. 20 plus 3.851 is equals to 23.851. This will be the height of our instrument. We will take a turning point 1 and move the stage rod and take a foresight reading of 0.948. So upon getting the elevation, we must subtract the foresight reading by the height of the instrument. So 23.851 minus 0.948 is equals to 22.903, which will be the elevation of turning point 1. And we move our instrument next and take a backside reading of 3.320. We will add the elevation and the backside reading so that we can get the height of the instrument. So 22.903 plus 3.320 is equals to 26.223 will be the height of our instrument. We will take another turning point 2 and move the stage rod because the point B is not visible to our instrument. So we will take a foresight reading of 0.780. So the foresight reading, subtract it by the height of the instrument so that we can get the elevation of turning point 2. So 26.223 minus by 0.780 is equals to 25.443. We will move our instrument and take a backside reading of 2.972. So upon getting the height of instrument, we must add the elevation and backside reading. So we got 28.415 as the height of the instrument. So in this case, the point B is visible by our instrument. So we will not add a turning point again. So we will move our stage rod at the point B, which will be our benchmark 2, and take a foresight reading of 0.945 and subtract it by the height of instrument of 28.415 minus 0.945, which will become up with 27.470 is the elevation of point B. So the difference in elevation between point A and point B is 7.470 meters. 27.470 minus by 20 meters equals to 7.470 meters. That's all.
Good afternoon, everyone. My name is Juharto M. Tamantok. So my presentation is all about profile leveling. Profile leveling is a generally adapted to find elevation of points along a line such as for road, rails, or river, etc. The purpose of profile leveling is to determine elevation along a purpose or existing road. So here are the equipments used in profile leveling. First is steel tape, next is automatic level, third is tripod, surveyor's rod, and last field book. So the first one is steel tape. Steel tape is a tape of cloth, paper, or steel marked off in a linear scale as of inches or centimeter for taking measurements. It is also known as linear tape. Next is automatic level, an optical instrument used to establish or verify points in the same horizontal plane. Next is tripod. Tripod are used for both motion and still photography to prevent camera movement and provide stability. Next is surveyor's rod, a graduated rod used in measuring the vertical distance between a point on the ground and the line of sight of surveyor's level. Last is the field book. Surveyors use field books to record survey data and notes as surveys were carried out. That's all for profile leveling.
Hello everyone, this is Krista Joy Olive A. Balajang and I'm going to discuss about the source of error in labeling. So we have three types of source of error in labeling, which are the instrumental, natural, and personal. First, we're going to elaborate the instrumental error. Error due to imperfect adjustment. The permanent adjustment of the instrument may not perfect. The line of the collimation may not be parallel to the axis of the bubble tubes. Error due to sluggish bubble. If the bubbles is sluggish, it will come to rest in wrong position. Error due to defective joints of stall. Joint of extendable leveling stop may be worn out after using for a long period. Last, error due incorrect graduation. The graduation of the leveling stop may not be perfect. The next source of error is natural. Refraction. Due to refraction, the ray of the light bends downwards, which decreases the stop readings. Next, Earth's curvature. On sighting long-distance effect of the Earth's curvature increase the staff reading. Settlement of tripod or leveling stop. The readings will be incorrect if the leg of tripod settles in the soil. Settlement of leveling stop at the change point B over W taking Fs and Bs will also produce error. Variation in temperature. The adjustment of the instruments may be disturbed due to unequal heating of the instrument. Last, effect of wind. The effect of high winds may disturb the instrument as well as the leveling stop. The last source of error is personal. The instruments may not be labeled perfectly. The focusing of the eyepiece and object glass may not be perfect and the parallax not be eliminated. The position of the stop may be displaced at the change point at the time of taking Fs and Bs reading. The stop may not be properly and fully extended. Mistake in reading the leveling stop. mistake in recording the reading to the field book, and last, mistakes in computation.